Welcome to our Quantum Deep Dive. Today, we're exploring the future of knowledge itself, and it's a wild ride. This is all based on a fascinating essay, Quantenwissen's Graph Construction by Jörg Ove. We're going to break down how the bizarre rules of quantum mechanics could totally reshape how our computers see the world.
So, let's kick things off with a question that really gets to the core of the problem. I mean, think about it. Our world is messy, it's ambiguous, it's full of context, but all of our digital tools, they're built on a foundation of absolute ones and zeros, yes or no. That gap, that fundamental mismatch, is exactly what we're going to tackle. Here's our game plan. We'll start by looking at where today's technology is hitting a wall. Then, we'll take a leap into the quantum realm, see how you can actually fuse these two worlds together, and then really dig into the power, the real-world challenges, and the incredible future of this new form of intelligence.
All right, first up, let's talk about the cracks that are starting to show in our digital world. Because to really appreciate where we're going, you first have to understand what's holding us back right now.
You're looking at the hidden brain behind things like Google Search and Siri. It's called a knowledge graph. It's this giant structured map of facts. So instead of just seeing words, it actually understands that Albert Einstein is a person, relativity theory is a concept, and the relationship between them is developed. It connects the dots for us.
But here's the problem. These systems are hitting a wall. The more information we cram into them, the more impossibly complex they become to manage. And they really struggle with the messiness of a real language. You know, like figuring out if Jaguar means the luxury car or the big cat. For them, that's a huge challenge. And all this means that discovering new insights gets really slow.
Okay, so to get past these limits, we need a totally new set of tools. And we're going to borrow them from the very strange, very powerful world of quantum mechanics. It is time to move beyond simple on or off switches. And it all comes down to this, the huge difference between a bit and a qubit. A classical bit, what's in your phone and your laptop, is just a light switch. It's either on or off, 1 or 0. Simple. A qubit, though, well, a qubit is more like a spinning coin. It's both heads and tails at the same time, existing in this cloud of probability. And that ability to be in multiple states at once, that's its first superpower.
Right. And that superpower has a name: superposition. This is what allows just one single qubit to hold and process a mind-boggling amount of information all at once. So instead of checking possibilities one by one by one, a system of qubits can explore this massive landscape of potential answers all at the same time.
The second superpower is entanglement, and this is where it gets even weirder. If superposition lets one qubit do many things at once, entanglement lets multiple qubits act as a single entity. Just think of them as a pair of magic coins. If you flip them and one lands on heads, you know instantly that the other one is tails, even if it's on the other side of the universe. It's this deep, spooky, instantaneous connection.
So, we've got the organized structure of a knowledge graph on one side and the incredible power of quantum mechanics on the other. What in the world happens when we fuse these two worlds together?
Well, here's how you can think about the upgrade. A classical node is just one thing. It's Jaguar the car, period. But a quantum node, thanks to superposition, can be Jaguar the car and Jaguar the animal at the exact same time. And the relationships, they transform from these simple fixed lines into dynamic fluid links created by entanglement, which can capture much more subtle and complex connections.
So what does this all really mean? It means a quantum knowledge graph, or a QKG, can handle ambiguity and uncertainty as a core feature, not as a bug to be worked around. It's basically designed from the ground up to see the world in shades of gray, just like we do.
Okay, so we've got this powerful new structure. It sounds amazing in theory, but what can it actually do? Let's take a look at the new capabilities this thing really unlocks.
Yeah, the benefits here are just transformative. They directly attack all the weaknesses of the classical systems we talked about. Because of superposition, it can analyze countless relationships at once. It's built for uncertainty. And thanks to special quantum algorithms, it can search for information and draw new conclusions with absolutely incredible speed.
Now this might just look like some math on a screen, but trust me, this is huge. This represents the search speedup from a famous quantum tool called Grover's algorithm. And to put it into perspective for you, if a classical computer had to look through a list of 1 million items to find one thing, it might have to take 1 million steps. A quantum computer using this principle could find it in about 1,000 steps, the square root of 1 million. It's not just a bit faster, it is a monumental leap in efficiency.
This all sounds pretty amazing, right? But the big question is, how close are we to actually building one of these? Let's bring ourselves back down to Earth for a second and look at the real-world state of the technology today.
Well, building the hardware is a massive, massive hurdle. You've got all these major players betting on completely different technologies to create the qubits themselves, from the super cold superconductors that IBM and Google use to the more stable but incredibly complex ion traps. Every single approach has its own pros and cons, and it's this huge engineering race to see which one will ultimately win out.
And this puts us in what researchers call the NISQ era. That stands for Noisy Intermediate Scale Quantum. It means that today's quantum computers are powerful, yes, but they're also noisy. They're incredibly sensitive to their environment. Tiny vibrations, temperature changes, which causes errors. And that's why, for right now, the most practical way forward is a hybrid approach, where classical computers work alongside their quantum counterparts to help manage and correct them.
So, based on the research, here's a possible roadmap for the future. In the next few years, we'll probably see these hybrid systems tackling very specific, very hard problems in fields like finance and medicine. A bit further out, maybe 5 to 10 years, they could be powering much smarter AI systems. And then long-term, we could be looking at the backbone of a completely new quantum internet.
And this all brings us to the biggest question of all. What does a world with quantum knowledge graphs actually look like? I mean, what happens when our machines can navigate complexity and uncertainty even better than we can?
Well, the applications are pretty much limitless, and they could change the world. Imagine discovering new life-saving drugs by perfectly simulating how molecules interact. That's a task that's basically impossible for today's computers. Or building truly intelligent AI agents that can reason with nuance and context, or financial models that can see market risks with a depth we can't even comprehend right now.
This quote from the author, Jörg Owe Schneppet, really nails the long-term vision. By putting quantum machine learning together with these knowledge graphs, we're not just making faster computers. We are aiming for a fundamental shift in what computation even is, leading to a completely new kind of intelligence. And so, we'll leave you with this final, pretty provocative thought. As we create these systems that can understand complexity and context and uncertainty on a level that might even surpass our own intuition, what does that mean for the future of humanity? Are we just building a new tool, or are we building the mind of our successor? It's more than just a tech question, it's a philosophical one.
Thank you for joining us on this quantum deep dive. To go even deeper, we really recommend you check out the source essay and other works by Jörg Owe Schneppet over at schneppet.de.
Goodbye.
Schneppet.de is a private project by Jörg Owe Schneppet dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.